we have Anuj Gupta, who is from fourth year and cracked Josh. So over to you, Anuj.
Yes, hello everyone. I'm Anuj Gupta, and as you saw on the poster, also like today we will be discussing bit manipulation topic, and after that we will also have some doubt session. You guys can ask any type of doubts, and I will be clarifying them. Like I don't know everything, but yeah, I know little bit, so I can share that thing. So, Nikon, should I start with the topic or do I need to like do something else?
No, Bhaiya, you can start now.
Okay, just a second. Can you all see my screen?
Yes, Bhaiya, it's visible.
So, basically, today's topic is bit manipulation. I think everyone know that computer works on the system of bits like 0 and 1. So it is same thing. Like usually we do operations on an integer or character or any other data type, but here we will deal with the like original bits. So you might have heard that integer have 32 bits. So we will work with that, and yeah. So like main operations in bit manipulation are like left shift. I know my writing is not very good, so if anyone is not able to understand, you can let me know. So there is left shift, right shift, and like bitwise operator. So bitwise or bitwise and bitwise zor. So, talking about their symbolic representation, so left shift is denoted by this symbol, which you use for Cin. So it's basically yeah, same as Cin, and right shift is denoted by this symbol, and bitwise OR is denoted by single OR. Like when you talk about conditional OR, so you use double like pipe. This is called pipe operator. So bitwise OR we have only single pipe, and bitwise AND we have single and bitwise ZOR we have this ZOR operator. So like if we talk about uh, first thing is bitwise, sorry, it should be left shift. So left shift. So what happens is an integer have 32 bits. So like there are 32 bits. So suppose I have an integer like 00 something something something, and at the end I have 010. So those who know binary, so it is an binary value of 2. So if I do left shift of 2, then what happens is I will remove bits from this side, left hand side, and add bits from right hand side. Am I audible?
Yes, Bhaiya, you are audible. Hello, Bhaiya. Hello, Anuj Bhaiya. Okay, till then let me explain you the left shift operator. So if we talk about the left shift operator, then we have its sign will be like lesser than angular brackets twice. And what basically it do, like if we have our tool as Bhaiya explained, what is the symbol binary representation of 2. So if we left shift this, then we will get 4. That is on left shift we will shift the one bit towards the left side. Okay, that means there will be two zeros after one, so that is the representation of 4. Bhaiya, if you
Yeah, can you hear me now?
yes,
Hello.
Bhaiya. Yes, Bhaiya.
Yeah, so I was just on the left shift. So what I was saying is, like if we do left shift, so we shift bits like on the left hand side. So if I do left shift, so it will be basically same as multiplying by 2. So my bits will look like 0, 0, 1, 0, and all other will be 0. So it will be left shifted. Like I'm shifting my bits to the left hand side. So here we only insert 0 on the left hand side whenever we do left shift. So if we talk about its value, so it will be 4. So you can see that it is basically multiply by 2. And if I again do left shift, so it will be 1 0 0 0. So it is 8. So like if we need to multiply by 2, then also we can use left shift. And if I talk about like speed, so these bitwise operators are the fastest operator. So if you are doing like integer multiplication, then it will definitely take more time. But if we do like if we use bitwise operator, then it will be very fast. But yeah, one key point here is whenever you do any bit operation, suppose I have int I is equal to 2, and I want to do I left shift by 1. So I should always enclose these in bracket, because these bitwise operator has lowest priority, lowest precedence or priority. So these should always be enclosed in brackets. Otherwise, we will be getting wrong results. So yeah, it is basically same as multiplying by 2. So now if we move to right shift, so what happens is like in right shift, we insert bits from the right hand side. Like if we have 32 bits, so I will insert bit from this end and remove from this left hand side. So here it will go, like from here it will be removed, and I will add from here. But the point is, like whenever we are adding bits from the right hand side, we have to check the parity of the MSB. So suppose if a number is 100 and rest are zeros and 010. So if I do right shift, then since the MSB is already 1, so I will add 1, and all the other bits will be right shifted. So this will be dot 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 and 0 0 1. So yeah, you can see that I have removed this bit, and rest other bits are shifted to the right, and I have inserted one bit like set bit on the right hand side based on the parity of the MSB. And if I have a number 00 something like that, when I do a right shift of this, so as you can see MSB is 0, so I will only insert 0, so it will be same, and at the end 0 0 1. So you can see that 1 has been shifted to its right, so it is basically right shift. So here also we can say that it is kind of division by 2. Like if we talk about this number, it was initially 2, then it became 1. So it is kind of division by 1. but we can't always say that it is division. So it is division by 2. Sorry. So like we can't always say that it is division, because in this case you can see that the number has changed. So yeah, it is not division in every case. And now if we talk about other bitwise operators, so like bitwise and, so what happens is, suppose I have two numbers 2 and 4, so their bit representation will be 0 1 0 and 1 0 0. So if I AND these numbers, so I will have to take AND of all the bits, like in the pair of bits. So 0 and 0 will be 0, 1 and 0 will be 0, and 0 and 1 will be 0, so it will be equal to 0. So here we will take AND of all the bits at the same position, or same, you can say, place value, or yeah. And same is with bitwise OR. So we denote it with single pipe. So if I have two, so 0 1 0 and 4 is 1 0 0. So if I like take OR of them, so 0 or 0 will be 0, 1 or 0 will be 1, and 0 or 1 will be 1. So it will become this, like it is value of 6, I guess. So yeah, it is same as the and or we do in Boolean algebra, but here we have to do it bitwise. And same is with XOR. So if bitwise XOR, so it has this symbol. So if I have 2, so 0 1 0 and 4 1 0 0. So what happens in XOR is, if we have same bit, then it becomes 0, and if we have two different bit, then it becomes 1. So yeah, it is like that, and I will again get 6. So here also we are taking XOR of individual bits. So it works like that. And so you might be like wondering like what is the use of these bitwise operators. So I can say that sometimes like if you have a Sudoku problem, so you have to store there is a Sudoku, and you have to store like what numbers have been used in this row and what numbers have been used in this row. So you can store all of them in bits. Like you can take a single integer, and like a zeroth bit will denote 0 and one first bit will denote 1, and you can set them and unset them based on like whether you have used or not. So it basically saves a lot of space. Suppose you have like in Sudoku, it is basically a 9 cross 9 matrix. So if you make a array of size 9 for every row, then it will take a lot of space. But if we use bit, you can like declare one integer variable for one row. So it will be basically 1 by 9th of space. So we can use it in that place also. And there are other questions as well, like where we can solve them easily by using bitwise operators. So now I think Ujjwal will show some, like solve some questions. So Ujjwal, are you here?
Yes, I'm here, Bhaiya. I can start, right?
Yeah, you can start.
Yeah. So I guess you have to stop your screen.
Yes.
Okay, is my screen visible, right? My screen is visible, right?
Yes,
Yes,
Ujjwal.
it's visible.
Okay, so starting off with bitwise operations, the most common problems are usually the ones which involve some sort of calculation for the number of set bits in a number. For example, we have a number like let's say 9. Okay, so let me just use a workpad instead. Let me just get rid of it. So let's say we have a number 9. The binary representation of 9 is like 1001. So the number of ones in the binary representation of a number are actually its bit count. So the bit count of 9 is 2. So how do you find the number of bits of a number is very easy. You just write it in binary form and just left shift it till the time it is greater than 0. Till the time n is greater than 0, I'll just left shift it. For example, in this case, n was 9. So I'll just left shift it. My last bit is 1. So I'll add 1 to my answer. N is now 4. I'll again left shift it. The last bit is not 1. So I'll not add anything. And in the end, I'll have 1. So I'll add 1 to my answer. And now n becomes equal to 0, right? If I left shift it from this orientation, I'll get n equal to 0. So in C++, we can write a function for it. For example, let's just say, and to outputs the bits of a number, I'll just declare a function, right? And let it be initially 0. So while I have my n, I can do if the last bit of n is if n is 1, then I'll do answer plus plus, and I can just left shift n by 1 times, right? And I can return answer from here onwards. So this is like the most basic question you can have. Let me use 9 as an example. So this is like the most basic question you can have. See, I'm getting 2, right? So if I use for another number, let's I use 3. Like 3 is represented as 11 in binary. So that also has 2 bits. For 4, it should be 1, right? So
Ujjwal, can you explain a bit of mechanism, like what is happening in this code, step by step?
As I said, so let me use this instead. Yeah, so initially my number was, let's say 9, let's say 4. So its binary representation is 100. I left shifted 1 time. My last bit is not 1, so I don't add anything to my answer. My answer is still 0. I left shifted. It's now 10. My answer is still 0. I left shifted again. 4, it remains out to be 1. My answer is now incremented by 1 because the last bit is 1. And I left shifted and I break the loop because now n is less than 0 or equal to 0. And my answer is returned to be 1. That's in C++, you also have a inbuilt function for it called built-in pop count. I guess it is like this. It's better to define the stuff. Yeah, see, I'm getting the same answer. Let me just. So it's all of this code is reduced thanks to the new C++ function, thanks to these inbuilt functions. So if I enter 9 again, I'll get 2 again, but I don't need to write that much of code. I'll get the same answer. So this is the most important part of it. This function is actually really helpful when it comes to contest and contest problems, because it reduces a lot of time in terms of writing code down. I mean, I can't write the same function over and over again, right? So it is much better to use it instead. So moving on to the question part, let me just, this is the, I have some questions with me here. These are like based upon the beginner level. So let's just go to this question first of all. So just read it for a second, and I'll hold on here for a minute, and you can give it a read. So what's happening in this question is I have been given 2 integers, a and b, and I have to reduce their sum with after taking their XOR with a number for any x. So I have this liability to decide x, right? I have been given the choice to decide x such that after I do a's or x plus b and I take its sum with b's or x, it should be, the sum should be minimum, right? So for example, let's take the first test case, right? 6 and 12. So taking their XOR with 4 actually reduces it. and I have to output the sum. I hope the question is clear. If somebody has any doubts regarding the question, I can. Does someone have any doubts regarding the question, or is it clear? I hope it's clear.
If anybody has any doubt, then you can unmute yourself and talk to him so that we know.
Okay, cool. So, yeah, let me just explain. So, in most of the bit manipulation questions, it is all about deciding how the bits are reduced. So, I have to decide x in such a way such that the sum the sum of the two numbers after taking their XOR with x respectively is minimized. So what can I do? Clear this again. So what can I do is I can say, like, let's say my x is somehow let's say my a is 6, let's take the example, and b is 12. So in binary, 6 is 110, right? And 12 is this. 12 is 1100. Okay, let me just write it all again. A is 6 and B is 12. Right. Uh, 6 is like this and 12 is like this. So what number should I choose here such that its XOR with both of them is reduced? So if I choose a number for A to reduce its sum, taking XOR with any number flips the number, right? So if I choose, let's say, there's no point in choosing a number to flip 0, because 0 actually means that the sum is being minimized. So I'll not do anything for it. I'll not do anything for it. Now, if I try to make this 1 into a 0, this 0 will end up turning into a 1. If I flip my 1, my 0 will be flipped in the different number. Right? It's all observation. There's nothing too smart to be too smart about it. It's just observation. So in this case, when I come to the second bit of both the numbers, I can see that both the bits are already set to 1. So it's better to flip these bits, right? Instead, it's better to flip these bits. And what would this? And I should use like 0 instead here. I should so here I can have 0 and here I can have 1. I should have 1 because 1 it would flip both of these bits, and in this case the same as the previous one, it should be 0. So a better way here would be to take the XOR of A with A and B, and to take the XOR to take the, and add with the B with A and B again. So X is meant to be A and B. That is what my intuition tells me. That is what I have observed in this question. So let me just write it down again. There's nothing to code in this. I mean, there is. I'll take my two numbers and I'll just output my answer to be A plus. As Anuj Bhaiya said, the precedence matters a lot in these questions. So one should always be very careful about it. A and B, right? And I can just output my answer. And I have test cases as well here. So, and okay, so I'm pretty sure it's correct. Yeah, it's correct. But one I leave it to you as an exercise. So it's if I just do A's or B, I'll get the same answer. And yeah, it's just the same answer. It's a A question of a contest. It's not going to be that difficult in the end. So should I submit it? is, I mean, it is not my main account I'm using, so might as well submit it. So it's a, we have an AC on this, right? So moving on, these three questions are actually very important. Unique number 1, 2, and 3 on lead code. I would I would actually recommend you to check it out. So I'll just explain the basic part of this. So let's say I have an array in which I have some numbers. Let's say 2, 2, 3, 4, 3, 3, 2, and 3. So I have to tell the unique number out of these. Every number occurs twice or more than twice, but just one number occurs once. And the better way to solve this is take XOR of all the numbers. Take XOR of them, and where you'll realize when you take the XOR of a number with itself, it actually turns out to be 0. So every 2 will cancel out every other corresponding 2, and same goes for 3, and in the end we'll have 4 as our answer. And this is just a basic subset question from CodeChef. I have tried it before. So yeah, this question is actually in bit manipulation. Brute force approaches actually work when the constraints of the question are quite low. So in this question, you can see that n is only till 20. I mean, in fact, I have a better one instead of this. I guess this is a much better question. Yeah, we can check here that n is only till 15. So I hope you're all familiar with the inclusion exclusion principle. I'll just write it down if nobody has heard of it. It's a very common concept from set theory that if I have two sets A and B, then the number of elements which exist in their intersection will be equal to n of A plus n of B minus n of A intersection B. Sorry, the number of elements which exist in entirety. It's going to be this for the number of elements in the entire set. It can be further generalized to a form where we can say that all the odd number of times the one is occurring, it will be added. For example, for 3 elements, we usually have it as n of A plus n of B plus n of C, and I will subtract n of A intersection B, and I'm sorry about my handwriting, minus n of B intersection C, and subtract minus n of A intersection C, and then add A intersection B intersection C. So there's a very general formula for it. Every time the number of elements which are being considered, if they are even, I'll subtract it from my eventual answer. And if the number of elements being considered are odd, then I'll add it into my respective answer. So for this question, we have some rotations given to us, and in the end we have to tell that if I rotated 10, let me take the first example. So in this case, if I'm allowed to rotate it 10 in either clockwise or anti-clockwise direction, 20 in either clockwise or 30 in either, in the end I have to say that can I reach a certain 0. So if I go 10 in this direction, so let me do this like this. So if I go 10 in this direction, I can go 20 in this direction and then 30 in this direction, which leads me back to 10, which leads me back to 20, right? So it is not, in that case, the answer would be no. But I can use, it's not necessary to use these rotations in the order in which they are mentioned. So let's say if 10, 20, 30 is mentioned, how many subsets are possible? So this is a very general formula for it as well. It's 2 raised to power n minus 1 subsets. So either I can take 10 or I can not take 10. So it's 0, 1. For 20 as well, it's 0 or 1. For 30 as well, it can be 0 or it can be 1. I can take it or I cannot take it, right? So the number of subsets will be totally, it will they will be 8 minus 1, which is 7. Right? I don't take any of them. I take one of them. I take that one can be either one out of the three, or I can just take two of them at a time. I mean, you get the point, right? And in the end, you can take three of them. So uh, this would actually tell us, after considering all of these cases in a brute way, we would get a certain configuration. One of these configurations has to match so that eventually we end up at 0. 0, 0, 0 can't be considered because obviously we have to take something. So that's the entire question here. You have to choose these in such a way, you have to choose their orientation in such a way such that uh, in the end I can have my pointer back to 0 or back to a certain value which is a modulus of 360. That is again a good point to be considered here. If I'm able to return to a point which is a modulus of 360, then obviously I'm returning back to 0, right? Which at a point which gives a modulus of 0 with 360. So I'll just code it out again. In these cases, in these questions, in the questions which involve like brute bit masking, you'll always see that the constraints are very small because it can only go up to a certain value. Because in this case, let's say if n is 15, I'm considering 2 raised to power 15 choices, which is already quite a large number. So I'll just use this instead. Uh, so let us solve this question instead. Let's say I've been given, there are no test cases, right? So I've been given some numbers and I can take them up in an array. And in the end, I have to search for a suitable configuration. So for int I is equal to 0, I less than uh, 1 raised to power n minus 1, right? Because I'll check all the possible configurations and I'll see if one of them is optimum or not, right? And I'll take my sum initially 0 for every element of the array. I'll check if I and 1 raised to power j, if that bit is already set, it means the rotation will be clockwise, so I can add it. Else the rotation will obviously be, it will be a 0 and the rotation will be anti-clockwise because I have to rotate in some direction. I can't just ignore the value, right? Otherwise I can just subtract the value, and in the end I can check if sum modulo 360 is 0, then obviously I can just output it and return from here. So this should work. Yeah, so this is possible. 120 is possible because I can rotate in clockwise direction. Like I can go 120, 120, and then again 120. I'll return back to 0. So let me try out for another test case. Yeah, for this it's possible as well. Let me try out for something which is no. Yeah, so I mean it can be submitted. So I have an AC on that as well. There are other questions. As well. For example, let me just take this question instead. I hope this question was clear to everyone. If there's someone has a doubt regarding it, I'm welcome to answer it. Does somebody has queries regarding that question, or should we move on? Okay, cool. There are other questions which I did select. For example, yeah, there's this question, right? I was talking about. There was this question where you are given certain coins of certain denominations, and you have to tell if their sum in either way is possible to a certain value. So, in a certain example, let's just take the last example. Okay, it's a large data set. So, yeah, for example, here I've been given three coins, and I have to tell whether the any combination of these three coins ends up giving a sum of three. So obviously, I can take all the three coins and I'll get three as my answer. So it's a similar question. You can try it out. I'll link it in the chat. Mm, Other questions are, yeah. So bit masking usually is not that much of a complex topic. It's more about its involvement with dynamic programming. When DP is involved, it actually leads to um, quite a complicated. It ends up being quite a complicated subject. So in this case, you can see the constraints are very low. They are like literally very low. They are almost nothing. But the answer will be so large that you have to take a modulo. You have to take a modulo with a certain value. In this case, dynamic programming will be used obviously because I have to count the number of possible orientations. Yeah, so I didn't explain the question. This is a question about there are 100 people. There are 100 different kind of shirts, and each person has a certain number of shirts with a different number, and you have to tell if there is any possible orientation such that every person wears a different shirt. So for example, here I have two people, right? I can just explain this in okay. Yeah, so here I have two people. Person number one, person number one has shirts of number 3 and 5. Person number two has shirts of number 8 and 100. Obviously, there now we have to check for a way such that all of them can go to a party and all of them have a different numbered shirt. Obviously, there are no clashes. Both of them own unique pairs, so the total number of ways will be 4. It can take 3, it can take 100 or 8, it can take 5, it can take 100 or 8 again. So for the second question, for the second test case, the person one has okay. For the second test case, person one has shirts of color 300 and 1. Person 2 has shirts of color 2. Person 3 has shirts of color 5 and 100. Right? So obviously, when person 1 decides to wear the shirt of color 100 or number 100, then person 3 can't choose 100. Right? So it can't be counted. Or if person 3 decides to wear 100, then person 1 shouldn't choose 100. So you have to count unique ways. In this case, also the answer is 4. I mean, you can just check it out. It's 3, 2, 5 or 100. So that's one way. That's two ways. Plus, if it wears 100, there is only one way. If person 1 wears 100, 2 always has one way, 3 will only have one way. So it's only one way again. If person 1 wears 1, then again there are two ways. But there's just one way because because person 3 can't wear the same shirt. So this is I can't do this, but I think it will be a bit over the top if I start with dynamic programming in the very first lecture. So these are like very easy questions. These are some easy questions based on bit masking. This is actually a very difficult question. This Sarija and LCM. It involves some sort of a technique called matrix exponentiation, which is this is insanely hard. It's not even just hard, it's insanely hard. It involves matrix exponentiation of certain values, and you can see the constraints are not small, they're actually quite large. So this is an interesting question. You can check it out if you want to. I'll link it in the chat as well. So with bit masking, it's all about observation as far as the questions are concerned. It's all about observations. And these three questions, especially unique number one, number two, and three, these are very popular interview questions. They're usually asked in almost every interview I've seen.
Ujjwal, can you link all the questions in the chat box?
Yeah, I'll link. I'll send it to you later. I'll probably text it in the group with
Okay.
proper links. I haven't searched them up on LeetCode. I know that they exist. I've solved them at certain point. But yeah, so I hope this was clear.
I
That
will link
was
it.
all as far as basic concepts are concerned. If we want to, we can talk more advanced stuff in the future. But I think that is good enough for the very first session. If anybody has any doubts, um, I'm here to answer it.
You can ask any doubts regarding the program code to go or a weekly session or any topic. There are no restrictions for the doubts. As I have seen that many of you are not solving questions. Can somebody answer why?
For further sessions, I think Nikunj will be responsible for the topics. I think we'll have a poll again if you want any further sessions. Apart from it, as far as bitmasking questions are concerned, I'll link them up. I'll send it in the group, and if there's anything, if somebody has any doubts regarding it in the future, I'll be welcome to answer it.
I think that's all for the session. So if you guys have any doubts, then you can ask them now, or please fill the feedback form and let us know that how we can improve for the program, and why you're not solving questions, so that we can help you out with that too. किसी को कोई डाउट नहीं आया बे? तुमको समझ आया?